What should the dimensions of the new garden be if it is to have the largest possible area? Show 2 ways to solve this problem. Okay, so we already know the area is going to be like times width, so 100x times 2x squared. And then,
Do you want to first identify like exactly what we think the problem's asking?
yeah.
So you have 100 yards of fencing in total. You want to wrap it around this rectangular garden, and it's only the X. It's not including this long term.
Yeah, that's
Yeah.
already
Right. You can think of that as like,
The wall.
yeah, like the house or something like that. So,
Because basically you have, like Annie said, like you have 100x minus 2x squared is what the area is. And is it asking basically you to solve the, basically to find the x that gives you the largest value for 100x
Yeah.
minus 2x squared?
mm-hmm.
With the constraint that
With the, yeah,
you have only 100 in total.
yes,
Okay.
yeah. Mm-hmm.
Yeah, but when doing it, you just have to remember that we don't have to do one of the sides.
Yeah.
So, suggestions.
So the area doesn't change, but the perimeter does.
The perimeter would change.
Okay, so the perimeter is going to be the x plus 100 minus 2x.
Yeah, for 100, yeah.
Well,
Yeah,
yeah.
Because you only have 100.
So the perimeter is always going to be 100 because
Right.
we have like
right.
bearing what x is. So this, I mean, this kind of relates to what, well, what to mention. So it has the largest area. Yeah. So it's like I'm going over with my students now, like derivatives, everything like that, in calculus. So it's like you could, well, currently it's derivatives and how that relates to like concavity and maximums and minimums and stuff. And I think this goes straight with that, where it's like if you were to make this into a function, you could then find the absolute max and the absolute min, considering it's a closed interval. Like we only have 100 yards of fencing. So that would be one way to go about doing it.
What's another potential way that we could solve this problem?
Just start plugging numbers in.
Yeah, and then there's if you find two that like it's the flip point.
You have two have the same
Yeah, relatively the same.
total area. Yeah.
You'll have like an estimate of what it'll be.
Yeah.
It won't be exact.
What do you do?
Like when you stop increasing
okay,
area and
yeah,
start
100%.
decreasing area. Yeah,
Yeah.
I got you, Danny.
You could also like draw it out.
Mhm.
Like you could go like we could go like every like 5 or 10, and you can like draw it out and see like how many like blocks or whatnot like we have, and like visually like look at the area. So like
One of the drawbacks with that, not to criticize them, is like that's a lot of drawing, I feel.
yeah.
Um,
Would we want to try using the optimization that you're talking about, and then use drawing to kind of like check within a relative kind of buffers, you know what I mean, like buffer zone. Like so if we said like the answer was like a certain number, you could go like 10 above and like 10 below that
Mhm.
number, and just kind of check visually and see if that makes sense.
as in, yeah, okay, I see, yeah.
But I guess I'm wondering like if we already solved it, do we need to
Well, what could be interesting is if we do guess and check, like find whatever answer we get and then do it as an optimization where we have this nice formula. Do we get the same answer? Thank you.
edit that out?
She doesn't.
I'm wondering like are the two methods we use, are they supposed to be like related to each other, or are we supposed to get to the answer?
No, I think they can be like,
I think-
last time
because
we did one drawing, like, which was completely separate, like it didn't need anything from
Right.
one part of the other, like the other way we solved it didn't
Right.
really like,
Relate.
yeah. So I think it can be two separate.
I guess I'm wondering if it has to be two separate. Because the things we said right now are kind of like, let's do this to see if we can get close enough, and then
We'll
find
check.
the real answer using the other one. But it's like, don't we need to find the solution for something too?
Let's see.
I guess.
Well, we can't find a solution if we do guess and check.
Okay.
Cause like, if you have two students, like one student might actually use guess and check as a method.
Right.
I guess that's not really effective, but
There's a possibility.
like, I think this problem is like easy enough to see the solution without writing out a formula.
Should we try that?
Yeah.
So guess and check.
Guess and check. See if we can all come together with the same answer.
May I borrow a piece of paper from someone and never give it back?
Here.
Thank you.
Wait, I just thought of something. So for our guess and check, we only have to like check between like x equals 0 and x equals 50, right?
Yeah.
Right? Because it's like 100 minus 2x.
But you also have to remember, like I was doing that and forgetting the constraint of the 100-yard perimeter. Like, just remember that.
Right, so the biggest x can actually be is 25.
Yeah.
Isn't it 50?
No, because
Well,
if you plug 50 into the original equation, you get
Like the one side of b
it
was
was
0.
which isn't possible.
Yeah.
I got 25 by 50 would be. Jay, did you get that?
yes. You said 25?
Yeah.
Wait, what?
So x would be 25, and then if you plug 25 into the bottom, 100 minus 2 times 25 would give you 50. So the dimensions are 25 by 50, and that gives you an area of 1,250, and the perimeter stays at 100.
What numbers did you test?
Well, I started at 30, and then
Gotcha.
Yeah, I
So,
did 30.
yeah, working the other way.
If
So-
you did 30, it would be 30 by 40, right?
Yeah.
And that wouldn't give you
So I started at x
Yeah.
equals 5, and I built up by 5, and the area got progressively larger, and then at 25 is when it like peaked at its highest, and then it started climbing down at the same rate
Mhm.
as it went up. Yeah.
So I started at 1 and then went 10 and then did every 5 after that.
Oh, okay.
And then knowing that 25 was the biggest number we could get, I checked, when I saw that, I then went, that was getting bigger, I then checked 24. It was smaller, so I concluded that 25 had to be the biggest
Yeah.
number.
I basically did the same. I started at 10. You said you started at 10.
Essentially, yeah.
I also started at 10, then I went like 10 increments of 10. 10, 20, 30, 40. And then I saw between 20 and 30, it was like,
It went down.
Yep.
Or,
well, 20 and 30 were the same, and then it started going down. So I was like, oh, I'll just pick something in between 20 and 30, and then I picked 25, and then I checked 24 and 26.
Awesome.
I was trying to do multiplication in my head, and was doing some things wrong. But my plan was to start at 30, just like not necessarily halfway, but further down the line halfway, to see if I could figure out when it starts like decreasing again. And then I was going to go backwards from whatever that point was to figure out like when it stopped increasing, I suppose, or at least stopped getting higher. So, which is what increasing means. So, yeah, that was the way I did it. Okay. So.
So guessing and checking worked, but
well, we think it worked. See,
True.
It agrees with our optimization method.
yes.
So Johnny, you said something about making like a function out of our area formula.
Yes.
Can you explain that?
Yeah. So if we can treat area like a function, then it will. We can use all of the resources we have in regards to functions to find the rate of increase and decrease, and using like derivative rules and everything like that. Like the first derivative, we can find where it's increasing and decreasing, so we can actually find that point where it stops and changes from increasing back to decreasing. And I mean, if we wanted to go further, we could use the second derivative as well, but we only really need the first. So it's like a quicker way, in my opinion, to do the guess, like the same process we did with the guess and check. It's like it eliminates all of the other guesses, I guess. So
we're looking for the first derivative
So-
of length times width.
yes, exactly. And then by figuring out where that is 0, we find out where the slope is 0 in this given function, which in this case would be the area. So it's like where the area either stops increasing or stops decreasing, changes behavior.
So, or do you want me to give you guys another? I'm just gonna ask you. I'm getting started.
Yeah, what do you have?
I did, so the area is obviously length times width, so I got 100x minus 2x squared, as I said before. And then I took the first derivative, so I got minus 4x plus 100, and then set that equal to 0. So then I got x equals 25, which is what we're looking for. Awesome, okay.
And then once you get
And then
that,
you can plug that back
you
in.
just plug it back in. Yep.
Do we need to explain how it works? I guess if we did. Or in our paper, we do have to explain how it works.
I think we can
Yeah,
interpret the graph.
yeah, how you like interpret.
Okay.
And if we wanted to, I mean, if anyone has a TI-84 still.
I do.
Desmos.
Or I mean, yeah, you can use
Desmos
Desmos as well, just to like,
Boom, still have them.
Sweet.
Do you even use that?
No, never.
I'll pull it up on Desmos so we can see the,
Actually,
do you wanna see the graph of the function of the area, or the graph of the function of the derivative? Or the derivative of the function?
no, you can do both.
Okay,
both.
alright,
did I do something wrong? I got x equals 50.
So what'd you do? You got your formula?
Because you didn't distribute.
I didn't distribute it all. I was going to do it as a multiplication.
Yeah, I know, but you didn't take the derivative of this part, and you took the derivative of the outside part.
Derivative of the inside. The derivative of the outside.
Well, if you take it as 2.
These are two separate functions, so it'd be
So you
derivative of the first times the second. Yeah.
Okay.
So the derivative.
So negative 200, and then plus 8x.
What are you getting?
So
Like, where'd you get 8?
is that an 8 or
4.
Oh.
8 wouldn't be correct.
Wait, can you?
Eight's what I
read you're
wanted.
doing?
Well, so he's doing the product rule of, it's like he wrote it as x times 100 minus 2x,
Mhm.
and instead of distributing and taking the derivative that way, he did, it's derivative of the first times the second plus the derivative of the second times the first. So, yeah,
Oh, plus.
so that's probably,
That should be a plus there, right? Minus 2. Derivative of the first times the second
Wait, I got the right thing.
plus.
So it's
derivative of the second, so it's
1 times 100 minus 2x plus negative 2 times x. So then you get 100 minus 2x minus 2x, which equals 100 minus 4x. Set that equal to 0, and then you get x equals 25.
so you had, because you multiplied it, you had
Yeah.
200. Yeah.
Gotcha. Okay.
It's okay.
So I got the graph. So it's a little hard. We're gonna have to look at them
No, I still have it.
independently. But so this is the graph. One is the orange one. I think is the parabola, which is which is like our main function of area, and then the blue one is the derivative.
Could you zoom in?
Yes. So I can, but what's gonna happen is like when we Yeah, you're gonna like
Oh.
lose the top, but what I can do is I can zoom in on the high point and it can
Okay.
show us.
But you don't do this.
And they say that the high point is at,
25.
And then you
And then
check
the
where
area is.
and then if you look, the graph of the derivative,
is 0 at 25.
yes, is 0 at x equals 25.
Okay.
Yes.
And then anywhere where like the y would go negative is what doesn't work for this particular problem. Correct.
Well, when the y goes negative, that
Oh,
means
well,
like
that's
your area is
negative area, yeah.
decreasing.
Mhm.
But when the area
For-
function,
Yeah.
like when the parabola is like below the
Yes, that's what I
x
mean.
axis, yes.
Mhm. Sweet.
Okay.
So consensus answer.
So the dimensions are 25 by 50, and the area, or the max area is 1,250 feet or whatever units squared, yards squared.
Yes.
Okay.
I got that as well.
I agree.
That's what I have.
Perfect.